Tonight, we are not going to solve equations. You don't need paper. You don't need a calculator. You don't even need to know what calculus is. This is not a test. This is a bedtime story. And like all good bedtime stories, it has heroes, villains, drama, betrayal, and just enough pettiness to make you smile in the dark before drifting off to sleep. This is the story of two men, Isaac Newton and Gottfried Wilhelm Leibniz. Two geniuses, two rivals, two people who could have changed the world together, but instead spent years fighting like children over who got to say I invented calculus first. And honestly, the whole thing is hilarious because calculus is not exactly the kind of thing you expect people to fight over. It is not gold. It is not a throne. It is not a beautiful princess or an empire. It is math, just math, a way of measuring how things change. But if you ask Newton and Leibniz, this was not just math. This was glory. This was reputation. This was immortality. But before we even get to them, let's zoom out. Imagine the world before calculus. No one had invented rocket science. Literally. Rockets existed in fireworks and military experiments, sure, but the math behind how things move, how they accelerate, how gravity works, all of that was incomplete. You could throw a rock, you could shoot an arrow, but you couldn't predict the exact path with precision. Engineers and astronomers did their best with geometry and algebra, but there were limits, big ones. Imagine trying to describe how fast something is falling at the exact second. Not after a second, not after 2 seconds, at the exact moment. People knew speed and distance, but the idea of instantaneous change was a mystery. This mystery was the missing piece that held back physics, astronomy, even basic engineering. So when Newton and Leibniz both came up with a system to solve this, it was like unlocking the cheat codes for the universe. Suddenly, math had a superpower, the power to deal with motion, curves, growth, shrinking, infinity itself. That is calculus. And that is why the story you are about to hear matters. Because this was not a small academic squabble. It was the origin of modern science. The math that allows us to fly airplanes, send astronauts to the moon, stream videos on the internet, and even predict the weather. If you think about it, your ability to listen to me right now owes something to this feud between two brilliant but stubborn men. Now here is where the fun part begins. Newton and Leibniz were very different personalities. Newton was the grumpy genius who preferred to be alone. He once spent months locked in his room without talking to anyone, working, scribbling, calculating, probably forgetting to eat. He was the kind of person who, if born today, would spend 3 days straight coding an app in his basement and then refuse to release it because someone might steal his idea. Leibniz, on the other hand, was the smooth talker, charming, social, diplomatic. He loved language, philosophy, law, politics. He was the guy who could go to a party, quote Aristotle in Latin, flirt in French, and still have time to casually invent a new branch of mathematics before dessert. If Newton was the introverted genius, Leibniz was the extroverted one. You might already guess what happens when two people like this collide. Fireworks. Not the fun kind, but the bitter academic feud kind. But wait, let me set the stage properly, because the 17th century was not just some quiet background for math nerds. Europe at the time was alive with scientific revolution. Galileo had recently stared through his telescope and annoyed the church. Descartes had tried to rebuild philosophy from scratch, starting with I think, therefore I am. Kepler was busy describing planetary motion. Everyone was discovering something new. It was like Silicon Valley, but with powdered wigs and much worse hygiene. In this exciting world, the invention of calculus was the golden prize. Whoever claimed it would not just be remembered, they would be immortalized as the genius who gave humanity a new lens to understand reality itself. And so our bedtime story begins. Two men, two countries, two egos, both convinced they had been the first, both unwilling to give credit, both determined to fight for their place in history. What makes this story so delicious is how petty it got. You might imagine two geniuses calmly debating their discoveries with elegance and respect. No, this was more like an academic version of a celebrity feud. Imagine Newton as the quiet superstar who secretly keeps every insult written down in a notebook for 20 years, and Leibniz as the charismatic showman who publishes his version first and becomes instantly famous. Sparks were guaranteed. The feud became public. And then it became ugly. Accusations of plagiarism, insults hidden inside scholarly papers, committees formed to investigate, biased reports and angry letters flying across Europe. All over a math method that today every high school student dreads at 8:30 in the morning when their teacher says, "Open your textbook to chapter on derivatives." And yet, this was serious business. Reputations, careers, even national pride were on the line. England rallied behind Newton. Continental Europe supported Leibniz. It was not just two men fighting anymore. It was two mathematical armies clashing in slow motion, each side convinced they were defending truth itself. Now, I know what you are thinking. Who actually invented calculus? And the answer is frustrating but true. Both of them. Newton developed his version in secret, years before Leibniz, but Leibniz published first with better notation, and the world ran with it. Without Newton, calculus would not have existed when it did. Without Leibniz, calculus might have stayed hidden in unread notebooks. They were like two inventors building the same airplane at the same time on opposite sides of Europe. But of course, both wanted the glory, both wanted the credit, and that is why this story turned into one of the dirtiest wars in the history of mathematics. So tonight, as you drift off to sleep, you can imagine this. Two of the greatest minds in history, not clashing with swords, not dueling at dawn, not commanding armies, but throwing mathematical shade at each other with pamphlets, committees and snarky letters. It is petty, it is brilliant, it is hilarious, and it all began with the dream of measuring the universe. Welcome to the Great Calculus War. Before we get to the actual feud, let's pause and imagine a world without calculus. I know, that probably doesn't sound very dramatic. Who cares, right? Most people today would happily live without calculus if it meant no more terrifying high school math tests. But trust me, a world without calculus is like a superhero movie without the superhero. You still have a story, but all the good stuff is missing. Think about this. The year is 1600. Humanity is pretty clever already. We have ships sailing across oceans. We have cathedrals scraping the skies. We have artists painting ceilings so glorious you get a stiff neck just looking at them. We even have early scientists staring at the stars with new telescopes. But when it comes to describing how things move, we are kind of stuck. Sure, we can measure distance, we can measure average speed. If a carriage travels 20 miles in 2 hours, fine. That's 10 miles per hour, no problem. But what about the speed at the exact moment the horse sneezes? What about how fast an apple is falling halfway down from the tree? Nobody knew how to calculate that. It was like having a blurry camera lens. You could see the big picture, but not the details. And those details matter, because if you want to understand planets, you can't just measure Mars takes this long to orbit. You need to understand how its speed changes every single moment. If you want to build better cannons, you need to predict the curve of the cannonball in the air, not just where it lands. If you want to make clocks more accurate, you need to understand the swing of a pendulum second by second. In other words, the world before calculus was impressive, but it had a ceiling, a hard ceiling. Humanity could only guess at how motion and change really worked. And oh, people tried. They really tried. The ancient Greeks, for example, had ideas about motion, but they preferred perfect circles and elegant geometry. They did not like messy, real-life problems like this rock falls faster the longer it falls. That was not beautiful enough for them. Aristotle, bless his heart, had all kinds of wrong ideas about motion, like heavier objects falling faster than lighter ones, which, if you've ever dropped a rock and a feather in a vacuum, you know is completely wrong. Fast forward to the Renaissance. Mathematicians started making progress. They could describe curves, they could measure areas, they had algebra, trigonometry and geometry. They even had some clever tricks to approximate motion. But still, nobody had cracked the code of instantaneous change. That one missing tool kept science in chains. To give you an idea of how bad it was, let's talk about Galileo. Galileo was brilliant. He rolled balls down ramps and carefully timed them with water clocks to study acceleration. He figured out that objects fall faster and faster, not at a constant rate. Amazing discovery. But even Galileo couldn't write the exact equation of motion as it changed at every single point. He could describe patterns, yes, but not the precise mechanics moment to moment. He was missing calculus. It's kind of like trying to play chess without queens. You can still play the game, but you're handicapped. Science before calculus was brilliant, but limited. And this is where the importance of our bedtime story really sinks in. Because calculus didn't just improve math a little bit. It was the game changer, the big unlock. Without it, there's no Newtonian physics. Without Newtonian physics, there's no Einstein to build on top of it. Without calculus, you don't get satellites, GPS, rockets, airplanes, streaming services, smartphones. You don't even get roller coasters designed safely. Calculus is hiding inside everything modern. Let's make it fun for a second. Imagine trying to design a roller coaster without calculus. You could build a track and hope nobody dies, sure, but to make sure the turns don't break necks or the loops don't fling riders into the stratosphere, you need to calculate curves, forces, and acceleration in real time. Without calculus, amusement parks would be much more terrifying, and not in a fun way. Or think about medicine. Modern medicine relies on calculus to model how drugs move through the bloodstream, how diseases spread, even how medical imaging works. No calculus, no MRI. Doctors would still be guessing half the time. And here's a fun fact. Even predicting your next YouTube video recommendation uses calculus. Algorithms crunch changes in data constantly. So yes, calculus is partly responsible for you even listening to me right now. Kind of poetic, isn't it? But back in 1600, people didn't have any of this. They didn't even know calculus was possible. Imagine the frustration of brilliant thinkers staring at the stars, knowing there had to be a better way to describe motion, but unable to find it. That's the world Newton and Leibniz were born into. A world hungry for a tool it didn't know it needed. And here's the funny part. When calculus finally appeared, people hated it at first. Not because it didn't work, but because it was so powerful it seemed suspicious. Infinity? Instantaneous change? These sounded like dangerous ideas. Some philosophers thought it was cheating. Some theologians thought it was heresy. Even some mathematicians thought it was too sloppy. They called it the scandal of mathematics. But scandal or not, it worked. It explained falling apples. It explained planetary orbits. It explained tides, light, sound, heat. It was the missing lens, and suddenly the blurry world came into focus. Humanity had gone from watching a fuzzy movie on VHS to seeing the universe in high-definition 4K. So when Newton and Leibniz each came up with their version, they weren't just doing math, they were reshaping reality. And that explains why the fight got so ugly. It wasn't just a nerdy debate over symbols, it was about who would be remembered as the one who gave humanity its greatest superpower. And that's why, even though the feud is now centuries old, it's still worth telling, because in many ways the story of calculus is the story of modern science itself. And like any good story, it has drama, egos, and more than a few hilarious twists. So next time you hear the word calculus, don't think about endless homework problems. Think about the world before it existed, a world stuck in the dark, straining to see the truth. And then think of two men living on opposite sides of Europe, about to ignite one of the pettiest, funniest, and most important wars in the history of ideas. And that, dear listener, is where the plot thickens. Before we get to the actual feud, let's pause and imagine a world without calculus. I know, that probably doesn't sound very dramatic. Who cares, right? Most people today would happily live without calculus, if it meant no more terrifying high school math tests. But trust me, a world without calculus is like a superhero movie without the superhero. You still have a story, but all the good stuff is missing. Think about this. The year is 1600. Humanity is pretty clever already. We have ships sailing across oceans. We have cathedrals scraping the skies. We have artists painting ceilings so glorious you get a stiff neck just looking at them. We even have early scientists staring at the stars with new telescopes. But when it comes to describing how things move, we are kind of stuck. Sure, we can measure distance. We can measure average speed. If a carriage travels 20 miles in 2 hours, fine, that's 10 miles per hour, no problem. But what about the speed at the exact moment the horse sneezes? What about how fast an apple is falling halfway down from the tree? Nobody knew how to calculate that. It was like having a blurry camera lens. You could see the big picture but not the details. And those details matter. Because if you want to understand planets, you can't just measure. Mars takes this long to orbit. You need to understand how its speed changes every single moment. If you want to build better cannons, you need to predict the curve of the cannonball in the air, not just where it lands. If you want to make clocks more accurate, you need to understand the swing of a pendulum, second by second. In other words, the world before calculus was impressive, but it had a ceiling, a hard ceiling. Humanity could only guess at how motion and change really worked. And oh, people tried. They really tried. The ancient Greeks, for example, had ideas about motion, but they preferred perfect circles and elegant geometry. They did not like messy, real-life problems like this rock falls faster the longer it falls. That was not beautiful enough for them. Aristotle, bless his heart, had all kinds of wrong ideas about motion, like heavier objects falling faster than lighter ones, which if you've ever dropped a rock and a feather in a vacuum, you know is completely wrong. Fast forward to the Renaissance. Mathematicians started making progress. They could describe curves. They could measure areas. They had algebra, trigonometry, and geometry. They even had some clever tricks to approximate motion. But still, nobody had cracked the code of instantaneous change. That one missing tool kept science in chains. To give you an idea of how bad it was, let's talk about Galileo. Galileo was brilliant. He rolled balls down ramps and carefully timed them with water clocks to study acceleration. He figured out that objects fall faster and faster, not at a constant rate. Amazing discovery. But even Galileo couldn't write the exact equation of motion as it changed at every single point. He could describe patterns, yes, but not the precise mechanics moment to moment. He was missing calculus. It's kind of like trying to play chess without queens. You can still play the game, but you're handicapped. Science before calculus was brilliant, but limited. And this is where the importance of our bedtime story really sinks in, because calculus didn't just improve math a little bit. It was the game changer, the big unlock. Without it, there's no Newtonian physics. Without Newtonian physics, there's no Einstein to build on top of it. Without calculus, you don't get satellites, GPS, rockets, airplanes, streaming services, smartphones. You don't even get roller coasters designed safely. Calculus is hiding inside everything modern. Let's make it fun for a second. Imagine trying to design a roller coaster without calculus. You could build a track and hope nobody dies, sure. But to make sure the turns don't break necks or the loops don't fling riders into the stratosphere, you need to calculate curves, forces, and acceleration in real time. Without calculus, amusement parks would be much more terrifying, and not in a fun way. Or think about medicine. Modern medicine relies on calculus to model how drugs move through the bloodstream, how diseases spread, even how medical imaging works. No calculus, no MRI. Doctors would still be guessing half the time. And here's a fun fact, even predicting your next YouTube video recommendation uses calculus. Algorithms crunch changes in data constantly. So yes, calculus is partly responsible for you even listening to me right now. Kind of poetic, isn't it? But back in 1600, people didn't have any of this. They didn't even know calculus was possible. Imagine the frustration of brilliant thinkers staring at the stars, knowing there had to be a better way to describe motion, but unable to find it. That's the world Newton and Leibniz were born into, a world hungry for a tool it didn't know it needed. And here's the funny part. When calculus finally appeared, people hated it at first. Not because it didn't work, but because it was so powerful it seemed suspicious. Infinity, instantaneous change, these sounded like dangerous ideas. Some philosophers thought it was cheating. Some theologians thought it was heresy. Even some mathematicians thought it was too sloppy. They called it the scandal of mathematics. But scandal or not, it worked. It explained falling apples. It explained planetary orbits. It explained tides, light, sound, heat. It was the missing lens, and suddenly the blurry world came into focus. Humanity had gone from watching a fuzzy movie on VHS to seeing the universe in high-definition 4K. So when Newton and Leibniz each came up with their version, they weren't just doing math, they were reshaping reality. And that explains why the fight got so ugly. It wasn't just a nerdy debate over symbols. It was about who would be remembered as the one who gave humanity its greatest superpower. And that's why, even though the feud is now centuries old, it's still worth telling, because in many ways the story of calculus is the story of modern science itself. And like any good story, it has drama, egos, and more than a few hilarious twists. So next time you hear the word calculus, don't think about endless homework problems. Think about the world before it existed. A world stuck in the dark, straining to see the truth. And then think of two men living on opposite sides of Europe, about to ignite one of the pettiest, funniest, and most important wars in the history of ideas. And that, dear listener, is where the plot thickens. If you thought Isaac Newton was only obsessed with math, think again. The man was obsessed with everything. I mean it. When Newton decided to study something, he didn't just dabble. He dove in headfirst, locked the door, and didn't come out until either the mystery was solved or his friends were deeply concerned for his sanity. He was the kind of person who couldn't just taste a cookie. He had to break it apart, measure it, analyze the sugar content, figure out the chemistry of flour, and then spend 6 months wondering whether the cookie held secret messages from God. Let's start with the obvious. Newton was obsessed with mathematics. He created calculus, played with geometry, invented formulas for motion and gravity. But math was just one corner of his restless mind. He also became obsessed with light. He bought prisms, set up experiments in his darkened rooms, and stared at rainbows until he was convinced color was not some mystical property of objects, but simply light split apart. He even stuck a needle behind his own eye to see what would happen when you press on the retina. Yes, you heard that right. He poked his own eye, for science. But then it gets stranger, because Newton was equally obsessed with alchemy. To us, alchemy sounds like a joke. Wizards in robes trying to turn lead into gold. But in the 1600s, alchemy was half magic, half science, and people took it very seriously. And Newton? He was one of the most devoted alchemists of his time. He filled notebook after notebook with recipes for elixirs, experiments with mercury, theories about hidden forces in nature. Some historians even think he poisoned himself slowly with mercury from all those experiments, which honestly explains a lot about his mood swings. And then there was theology. Newton wrote more about religion than he ever did about physics. Thousands of pages, in fact. He studied the Bible with the same intensity that he studied the laws of motion. He tried to decode hidden prophecies in the book of Revelation. He calculated when the apocalypse would come, because apparently inventing modern science wasn't enough. He also had to predict the end of the world. This might sound eccentric, but it shows something about Newton's mind. He wasn't separating science, religion, and magic. To him, they were all parts of the same great puzzle. The universe was a mystery left by God, and it was his personal mission to solve it. Every force, every number, every beam of light was a clue. He was like Sherlock Holmes, but with worse people skills and much bigger hair. Now about those people skills. Newton was not exactly the life of the party. He avoided crowds, he avoided friends, he avoided basically everyone. He had almost no social life. No wife, no children, no stories of drunken nights out with friends. What he did have were endless obsessions and an ego that could block out the sun. One of my favourite Newton stories is that he once built a little windmill, powered by a mouse running on a wheel. He thought it was brilliant, and honestly it was. But imagine being Newton's roommate, trying to sleep, and there's a squeaky mouse-powered windmill running all night, because Isaac is busy measuring its efficiency. This was his idea of fun. But here's the thing, this kind of obsessive personality is also why he achieved so much. Normal people would stop. Normal people would say, okay, I think I've done enough today. Newton didn't have that switch. He could keep grinding on a problem until the solution gave up and surrendered. He could spend years thinking about why the moon doesn't fall to Earth, or why light bends, or how a curve should be measured, and eventually he cracked problems nobody else could. That doesn't mean he was easy to get along with. Far from it. Newton could be paranoid, jealous, and deeply insecure. If he thought someone was stealing his ideas, he would attack them with relentless fury. He kept grudges like they were trophies. One time, when a rival disagreed with him about the nature of light, Newton basically wrote him out of the scientific community. Imagine having a fight with your co-worker, and instead of arguing, they destroy your entire career. That was Newton. And yet, despite all his flaws, Newton's obsessions gave us tools that changed the world. His endless notes on fluxions, the beginnings of calculus, were part of that. His theories of motion and gravity built on them. Even his strange obsession with alchemy wasn't entirely wasted. Some historians argue that his alchemical experiments helped him think about forces and transformations in a new way, pushing him toward discoveries in physics. Still, it's fun to imagine. Newton, in his farmhouse surrounded by alchemy recipes, half-finished math notes, theological diagrams, a squeaky mouse windmill, and the occasional apple. A lonely genius, obsessed with everything, convinced he was chosen to solve the universe. And honestly, maybe he was, because this obsessive, sleepless energy is exactly what set him on the path to inventing calculus. Not neat, polished calculus like we use today, but a raw, early version. A strange system of fluxions and fluents, his own secret language of change. He worked on it for years, but true to his nature, he kept it mostly hidden, locked in notebooks, guarded from critics, as if the very act of sharing would ruin it. And that brings us to the heart of our story. Because while Newton was busy obsessing in secret, another man was obsessing too. But this man was very different. He didn't hide, he published, he charmed, he wrote with elegance, he gave calculus to the world. That man was Gottfried Wilhelm Leibniz. And when their worlds collided, it would set off the dirtiest, pettiest, and most entertaining math feud in history. Isaac Newton had a problem. Not the kind of problem most of us have, like forgetting where we put our keys or deciding what to eat for dinner. No, Newton's problem was much bigger. He was trying to figure out the rules of the universe. He had this nagging question: how do you describe motion, not just as a whole, but moment by moment? Everyone could say, a carriage travels 10 miles in an hour, but Newton wanted to know, what about at this exact second, right here, right now? How fast is it moving then? What is happening in that instant? This question haunted him. It was the key to understanding falling apples, swinging pendulums, planets circling the sun. Without a way to measure change in the moment, physics was like a half-finished puzzle, and Newton hated half-finished puzzles. So, in his usual style, he locked himself away and invented his own system. He called it the method of fluxions. The name alone sounds like something out of a wizard's spellbook. Fluxions were his way of talking about change, like tiny flows in motion. Fluents were the quantities that flowed. With this system, Newton could describe how things changed continuously, not just step by step. Now, here's the thing. Newton didn't exactly invent calculus the way we know it today. His notation was different, his style was clunky, and if you showed a modern math student his symbols, they'd probably cry. But the ideas were all there. Derivatives, integrals, instantaneous change, rates of motion. It was calculus, even if the branding was a bit medieval. And of course, Newton being Newton, he didn't rush to share it. He scribbled it into his notebooks, polished it a bit, and then kept it under lock and key. Why? Because he hated critics. He once said he didn't want to be baited by little smatterers in mathematics. Translation: I don't want amateurs nitpicking my genius. So he sat on it for years. This is the great irony of the calculus war. Newton had the goods. He really did. But because he refused to publish, history didn't give him the credit right away. And in science, as in life, timing is everything. Let's imagine an alternate history for a second. What if Newton had published his method of fluxions in the 1660s? The world would have instantly known him as the inventor of calculus. Leibniz wouldn't have had a chance. The feud might never have happened. We'd all be learning Newton's clunky notation instead of the beautiful symbols we use today, which, honestly, sounds like a nightmare. Imagine writing homework using Newton's scribbles instead of Leibniz's clean dx and 4. High school math would be 10 times worse. But Newton didn't publish. He guarded it. To him, knowledge was a treasure, and critics were thieves, and that decision shaped everything that followed. Still, even unpublished, his method was brilliant. He could calculate slopes of curves at a single point, predict acceleration, analyze orbital motion. These were not just tricks, they were tools that would reshape science forever. And here's a fun fact. Newton actually used his fluxions to solve problems in physics long before he told the world about it. When he later wrote his masterpiece Principia Mathematica, the book that laid out the laws of motion and gravity, the math inside was powered by calculus. But Newton, in his usual paranoid way, disguised it. He rewrote everything using geometry, so people wouldn't realize how much he was relying on his secret weapon. It's almost comical. Imagine writing the world's greatest science book, but hiding the very math you used to create it. That was Newton, a genius but also a control freak. Why did he do that? Well, partly because he wanted to avoid controversy, but partly because he thought geometry looked more respectable. He believed calculus was too new, too suspicious, too messy to put on display. Geometry, with its roots in the Greeks, felt safe and noble. Calculus was like a scrappy newcomer that hadn't earned its place at the royal table. But make no mistake, behind those polished diagrams of circles and triangles, Newton was secretly flexing with fluxions. His hidden calculus was the engine running the whole show, and this secrecy sets the stage for the feud with Leibniz, because while Newton was hoarding his treasure across Europe, another brilliant mind was busy inventing his own version. And unlike Newton, Leibniz loved to publish, he loved to share, he loved to dazzle the world with his elegance. But let's not jump ahead just yet. Let's stay with Newton a little longer, because his secrecy wasn't just about fear of criticism, it was part of who he was. Newton lived like a man on the edge of discovery and paranoia at the same time. He wanted truth, but he also wanted control. His notebooks from this period are fascinating. You can almost feel the intensity in the handwriting. Equations scribbled over the margins, diagrams of curves, endless calculations. It's like watching a brain on fire. But it's also lonely. Newton wasn't collaborating with others. He wasn't sending drafts to colleagues. He was an island, a brilliant, moody, sleepless island. And yet, even alone, he cracked the code. He built the foundation of calculus years before anyone else had it. He just couldn't bring himself to step into the spotlight. So when Leibniz finally did, history was ready, and Newton was not. But let's save that drama for later. For now, picture young Isaac, hunched over his desk, candles burning low, surrounded by scraps of parchment filled with strange symbols. Outside, the world is dark and dangerous, plagued by disease. Inside, Newton is inventing the math of motion, one fluxion at a time. A secret he thought was his alone. A secret that would soon spark one of the pettiest, funniest, and most important fights in the history of science. While Newton was busy hiding in farmhouses, poking his own eye with needles, and guarding his fluxions like a dragon on a pile of gold, another genius was living a very different kind of life. His name was Gottfried Wilhelm Leibniz. And if Newton was the grumpy loner who wanted everyone to leave him alone, Leibniz was the charming gentleman who seemed to know everybody, talk to everybody, and impress everybody. Leibniz was born in Leipzig, Germany, in 1646, about 4 years after Newton. From the start, he seemed like a completely different species of genius. While Newton grew up shy, isolated, and deeply suspicious of humans in general, Leibniz was outgoing, witty, and curious about, well, absolutely everything. And when I say everything, I mean everything. Philosophy, mathematics, law, politics, theology, history, linguistics, you name it. Leibniz had his hands in it. He was like a one-man university. He wrote papers on metaphysics, argued about the nature of God, worked as a diplomat, invented one of the first mechanical calculators, and still somehow found time to invent calculus. You almost get the sense that Leibniz never slept, which makes him the perfect rival for our story. The sleepless gentleman versus the sleepless mathematician. Here's one fun difference between the two men. Newton discovered calculus and then stuffed it into his drawer, glaring at anyone who came too close. Leibniz, on the other hand, invented his version and practically shouted it from the rooftops. He published, he shared, he made his notation elegant and easy to use. He wanted the world to see his brilliance, and the world actually loved him for it. But let's rewind a little, because before Leibniz became the calculus guy, he was already a superstar in philosophy and diplomacy. At just 20 years old, he had a doctorate in law. 20! At that age, most of us are still figuring out how laundry works. Leibniz was out there debating deep questions of justice, natural law, and the meaning of existence. And he didn't stop there. He travelled all across Europe, meeting kings, princes, and scholars. He was the kind of guy who could charm a court of royalty in the morning, debate metaphysics in the afternoon, and spend the evening designing a new counting machine. Imagine if James Bond, Albert Einstein, and a stand-up comedian had a child. That's kind of the vibe Leibniz gave off. One of his most famous ideas outside of calculus was his belief that we live in the best of all possible worlds. According to him, God, being perfect, must have chosen the best possible setup for reality, which is a comforting thought, unless you're Newton, who probably would have responded, "If this is the best world, why are people so annoying?" But Leibniz wasn't just a dreamer, he was also a builder. He designed a mechanical calculator called the stepped reckoner, which could add, subtract, multiply and divide. It was one of the earliest machines of its kind, and although it had flaws, it was a major leap toward computers centuries later. When you use a calculator on your phone today, you can thank Leibniz for getting that ball rolling. And then there was language. Leibniz dreamed of inventing a universal symbolic language, a kind of math for everything that could solve disputes logically. His dream was basically to create Google Translate, programming languages, and logic circuits all in one go, except in the 17th century with no electricity. Ambitious? Yes. Successful? Not quite. But you've got to admire the imagination. Now, let's talk about his personality. Unlike Newton, who seemed allergic to other humans, Leibniz was a natural diplomat. He could charm scholars and aristocrats alike. He wrote letters constantly, so many letters that historians say his collected correspondence is enormous, one of the largest archives of any historical figure. If Newton was the type to ignore his messages forever, Leibniz was the type to reply instantly with a 2,000-word essay full of wit, wisdom, and a few math equations for good measure. But don't let the gentlemanly manners fool you. Behind the charm was a razor-sharp competitor. Leibniz wanted to be remembered. He wanted to be the guy who brought light to the world, and when he discovered his own version of calculus in the late 1670s and published it in 1684, he knew he had a masterpiece in his hands. The thing that made Leibniz's version so powerful wasn't just the math, it was the notation. He invented symbols like Thurn for integration and dx for tiny changes. Elegant, simple, intuitive. If you've ever done calculus homework, you've seen his work. Those little symbols that make math at least look neat and manageable. That's Leibniz. Newton's fluxions, on the other hand, looked like a secret code designed to confuse everyone. It's no wonder the world adopted Leibniz's system. Teachers loved it, students loved it, scientists loved it. The only person who didn't love it, Newton. Because here's the kicker. Newton had discovered calculus earlier, but Leibniz had published first, and in science, publishing first is basically everything. Imagine Newton's face when he realized this. Years of scribbling in secret, guarding his fluxions like a paranoid dragon, only to see Leibniz waltz onto the stage with a smile, a bow, and a shiny new calculus that looked better, sounded better, and came with an instruction manual everyone could understand. Brutal. And this is where the tension starts to build. Leibniz wasn't trying to steal anything. He genuinely thought he had invented calculus independently, and to be fair, he had. But because he published first, and because his version was so elegant, he quickly became known as the calculus guy. Meanwhile, Newton fumed in the background, muttering, "But I did it first." So now we have our two characters fully introduced. On one side, Newton, the secretive, obsessive loner, scribbling fluxions in his notebooks, glaring at the world. On the other, Leibniz, the gentleman philosopher, publishing, networking, and dazzling Europe with his shiny new calculus. They were bound to clash, but the clash wouldn't just be about math. It would be about pride, reputation, and national rivalry. England versus continental Europe. The grumpy dragon versus the charming diplomat. And as you'll see, it would get very, very messy. For now, though, let's leave Leibniz standing in the spotlight, smiling politely, showing off his beautiful notation to a world eager to adopt it. He didn't yet know that across the channel, a storm was brewing, a storm named Isaac Newton. And when those two worlds finally collided, it wouldn't be a gentle meeting of minds, it would be war. If calculus is a language, then Isaac Newton invented a dialect that nobody wanted to speak, and Gottfried Wilhelm Leibniz invented the version that everyone adopted. This is one of those strange twists of history. Newton discovered calculus first. That much is true, but when you look at the way he wrote it down, you can see why the world chose Leibniz's version instead. Newton's system of fluxions was clunky, confusing, and honestly kind of ugly. Imagine a cookbook written in a secret code where every recipe starts with first. Assume the existence of a mystical flow. Not exactly beginner-friendly. Leibniz, on the other hand, had style. He thought deeply about how math should look on the page, not just how it worked in theory. He cared about notation the way a novelist cares about sentences, or a musician cares about melody. And when he introduced symbols like dx for a tiny change and Herthoring for integration, it was like turning on the lights in a dark room. Suddenly calculus wasn't just powerful, it was elegant. Let's pause on that strange S-shaped symbol, pattern. If you've ever seen it and thought, what is that squiggly thing? Congratulations, you're looking at Leibniz's genius. The hint comes from the Latin word summa, meaning sum, because integration is essentially adding up infinitely many little slices. Leibniz thought, why not make the symbol look like a stretched out S? Simple, logical, beautiful. And dx, those two little letters you scribble when taking derivatives, stand for a differential, a tiny change in x. Want to know how fast something is moving at a certain instant? You look at dx and dy, the tiny changes in x and y, and you get a clean, elegant formula. In Newton's system, the same idea was buried in strange dot symbols over letters, like a secret code only he could decipher. Students everywhere owe Leibniz a thank you. Without him, calculus might still look like a mess of dots, fluxions and fluents. Instead, it became a language the whole world could learn. Even today, scientists, engineers and students in every country use Leibniz's notation. Newton's system is now a historical footnote, studied mostly by historians who probably sigh and say, well, at least he tried. But the brilliance of Leibniz's notation wasn't just about aesthetics. It shaped how people thought about calculus itself. His symbols made it easier to generalize, to extend, to apply calculus in new areas. The clean separation of dx and dy, the Tarm sign, the clear rules, these weren't just decorations, they were tools that guided generations of mathematicians to new discoveries. It's kind of like the difference between driving a car with no steering wheel and one with a smooth, comfortable wheel that fits your hands perfectly. Newton's fluxions were powerful, yes, but awkward to handle. Leibniz's version made the ride enjoyable. And here's where the story gets funny. Leibniz, with his natural flair for communication, published his calculus in 1684 in a journal article that people could actually read. He explained his notation, gave examples, and showed the world how useful it was. He wasn't just solving problems, he was teaching. He was inviting others to join in. Newton, meanwhile, still had his notes locked away. Imagine his face when he saw Leibniz's paper. Not only had this German philosopher beaten him to publication, but he had also done it with symbols that looked better, worked better, and spread like wildfire. Now here's a fun twist. Leibniz didn't just invent nice symbols for math. He believed symbols in general were the key to human progress. He dreamed of creating a universal language of thought, a symbolic system where every idea could be expressed clearly and disputes could be solved logically. A sort of math-powered Esperanto. He never quite succeeded at that grand vision, but you can see the spirit of it in his calculus notation. Clean, universal, logical. It was math that spoke for itself, regardless of nationality or native tongue. If Newton's fluxions were a private diary, Leibniz's calculus was a public letter to humanity. And Europe loved it. Mathematicians on the continent adopted his notation eagerly. They used it to solve problems Newton's geometry-heavy style made clumsy. They extended it, expanded it, turned it into a full-blown mathematical revolution. Within decades, Leibniz's notation was everywhere. England, however, was stubborn, because Newton was English, and Newton had his own notation. The English stuck to fluxions out of loyalty. For almost 100 years, English mathematics lagged behind the continent, because they refused to use Leibniz's superior system. It was a kind of mathematical Brexit, centuries before Brexit was a thing. Only later did they finally give in and adopt Leibniz's symbols, realizing the rest of the world had moved on. So, in a strange way, Leibniz not only won the notation battle, he shaped the trajectory of mathematics itself. His symbols became the grammar of change, the alphabet of motion, the language of science. If Newton was the man who discovered calculus, Leibniz was the man who made it usable. But of course, to Newton, this was intolerable. He saw Leibniz's popularity not as genius, but as theft. In his mind, Leibniz had stolen the treasure he had hoarded for years. Never mind that Leibniz had likely discovered it independently. Never mind that Leibniz had brought it to the world with style. Newton, ever the paranoid, ever the grudge holder, began to see Leibniz as a thief. And so the stage was set. On one side, the gentleman philosopher with his elegant symbols and open communication. On the other, the grumpy dragon who believed his secret treasure had been stolen. This wasn't just math anymore. It was pride, it was ego, it was reputation, and soon it would become one of the dirtiest academic feuds in history. For now, though, let's appreciate the beauty of what Leibniz gave us. The storm sign, the dx, the clean, universal language of calculus, symbols that students curse today during late-night homework sessions, but symbols that made science, engineering, and modern technology possible. If you've ever used GPS, flown on an airplane, or streamed a video online, you've been touched by Leibniz's squiggly little s. You may not love it, you may have nightmares about it, but you can't deny it shaped the modern world. And soon it would also spark a war. If science were a race, Isaac Newton was the guy who sprinted ahead, crossed the finish line first, and then just sat down quietly on the ground, refusing to tell anyone. Meanwhile, Gottfried Wilhelm Leibniz strolled up a little later, waved to the crowd, and declared, "Ladies and gentlemen, allow me to present calculus." And of course the crowd cheered for him. This is the moment where the story shifts, because in 1684, Leibniz finally published his version of calculus in a scientific journal. That single act, more than Newton's years of secret scribbling, gave calculus to the world. The paper was short, clear, and brilliant. It wasn't some 800-page monster filled with paranoid ramblings, which is exactly the kind of thing Newton would have written. Instead, it was a tidy little piece called Nova Methodus Pro Maximis et Minimis, or a new method for maximums and minimums. Very catchy title if you're a 17th century math nerd. Inside, Leibniz explained how to calculate slopes, tangents, and areas under curves using his shiny new notation dx and dy, and the hundred symbol that looked like a long, elegant S. People loved it. Scholars on the continent devoured his paper. They started using it in their own work, spreading the notation, solving new problems, pushing mathematics forward. It was like someone had finally handed them the missing tool they'd all been searching for. Meanwhile, back in England, Newton was fuming. Remember, he had invented his method of fluxions nearly 2 decades earlier, back during his plague years, but because he never published it, the world had no idea. Now, here was this German guy smiling politely, saying, "Look at this amazing new method I've invented." And Newton thought, "That's my baby." To be fair, Leibniz probably wasn't stealing. Historians now generally agree that he discovered calculus independently. The timing was just awkward. Newton had the ideas earlier, but Leibniz gave them to the world first. And in science, it doesn't really matter if you thought of something first, if you never bothered to tell anyone. It's like claiming you invented pizza but you only told your diary about it. Then one day, a guy in Naples opens a pizzeria, and suddenly the whole world is eating pizza. You can scream, "But I did it first," all you want. But history is going to side with the guy who actually fed people. And Leibniz fed the mathematical world. His paper didn't just present calculus, it made it accessible. It gave people a system they could actually use. Within a few years, his notation had spread across Europe like wildfire. Mathematicians in Germany, France, and Switzerland were using it to solve problems Newton's clunky geometry couldn't touch. In England, though, things were different. The Royal Society, Newton's scientific home turf, was slower to embrace Leibniz's work, partly out of loyalty to Newton, partly out of national pride. The English stuck to fluxions. This decision would haunt them. For almost a century, English mathematics lagged behind the continent. While Europe surged ahead with Leibniz's elegant notation, England stayed stuck in Newton's secretive shadow. But Newton didn't care about the long term. He cared about his ego. And nothing bruised his ego more than seeing Leibniz hailed as the inventor of calculus. For Newton, this wasn't just math, it was personal. Now let's put ourselves in Leibniz's shoes for a moment. He had no idea Newton had been working on similar ideas decades earlier. Or maybe he did. There's debate about whether he saw some of Newton's early notes. But from Leibniz's perspective, he had discovered something groundbreaking, written it clearly, published it openly, and was now rightfully being praised for it. If Newton was sulking across the channel, well, that was Newton's problem. And this contrast between the two men is striking. Newton, the solitary dragon hoarding treasure, scribbling in notebooks nobody could read. Leibniz, the gentleman philosopher, sharing his discoveries, making them elegant, inviting the world to join in. No wonder Europe embraced Leibniz. But here's the twist. The world of science is not just about ideas, it's also about credit, about who gets remembered. And when two geniuses both want to be remembered as the inventor of calculus, you know things are going to get ugly. So what did Newton do? He started gathering evidence. He combed through old letters, old drafts, old scraps of paper to prove he had invented calculus long before Leibniz, and technically he had. But the world didn't care about technicalities. The world cared about what was published. Leibniz, meanwhile, just kept publishing, writing, and dazzling scholars. He wasn't perfect. He could be vain, ambitious, and a little too eager for glory. But compared to Newton, who was basically allergic to human contact, Leibniz came across as a saint. He was building networks, writing letters, making friends. He wasn't hiding in a farmhouse scribbling angry notes. And this, dear listener, is where the feud really begins. Because once Leibniz published in 1684, the clock started ticking. Newton couldn't keep quiet forever. The world now knew calculus, but it thought Leibniz was the father. And Newton was not going to let that stand. But we'll save that for later. For now, just picture this moment. A quiet journal in 17th century Europe prints a tidy little article. A German philosopher proudly shows off his invention. Mathematicians everywhere start clapping their hands, thrilled by this new tool. And somewhere in England, Isaac Newton slams his notebook shut and mutters, "That should have been me." It's almost Shakespearean. Two geniuses, one discovery, and the stage set for one of the pettiest, funniest, and most important academic wars in history. By now, the pieces were on the board. Newton had his secret fluxions locked in his notebooks. Leibniz had published his smooth, shiny calculus for the world to admire. And Europe was buzzing with excitement. But this wasn't just about two men anymore. This was about nations. England on one side, continental Europe on the other. And like any good rivalry, it was fueled by pride, politics, and the irresistible human desire to say, "Our guy is better than your guy." Let's rewind to the 1600s. England and Europe were not exactly best friends. The English scientific community was somewhat isolated. Travel was slow, wars were common, and languages were barriers. French, German, Latin, English. Scientists had to wade through translations and endless letters just to communicate. Ideas moved across borders, but they moved like snails. So when Leibniz published his calculus in a continental journal, Europe cheered. Mathematicians in France, Germany, and Switzerland quickly picked it up. They liked his notation. They liked his clarity. They liked that he actually bothered to share. Soon, Leibniz's version of calculus was the talk of the town in European universities. Meanwhile, in England, things were quieter. The Royal Society, the proud English scientific club, still had Newton's fluxions hidden away like family silver. Newton himself was not exactly rushing to share, so English mathematicians lagged behind. While Europe was calculating slopes, curves, and areas with Leibniz's elegant thundars and dx, English students were stuck with Newton's dot-filled hieroglyphics, if they had anything at all. This gap started to sting. The English saw Europe racing ahead in mathematics, and they didn't like it. National pride kicked in. It wasn't just about math anymore. It was about England versus the continent, about proving that the English lion could roar louder than the German philosopher. And at the heart of this pride was Newton himself. England adored him. He was already famous for his work on light and optics. He was a national treasure, a symbol of English genius. So when Leibniz began to gain international fame for calculus, the English didn't just see it as a scholarly debate. They saw it as a threat to Newton, and by extension, a threat to England's reputation. The irony, of course, is that Newton had the proof. He really had developed calculus earlier, but because he sat on it for decades, his country ended up on the defensive. Instead of leading the charge, they were stuck explaining why their genius hadn't published in time. It was like discovering electricity but refusing to tell anyone, only to watch your rival invent the light bulb and become famous while you sit in the dark muttering, "I thought of it first." Still, the English weren't about to let this go. Newton's allies began whispering, Leibniz stole it. He must have seen Newton's notes. He copied the method. At first it was just murmurs in letters and private conversations, but slowly those whispers grew louder. They started to circulate in academic circles, creeping across borders like rumours at a family reunion. Leibniz, of course, denied it. He insisted he discovered calculus independently, and the evidence today suggests he was telling the truth. But in the heat of rivalry, truth doesn't always matter. What matters is who controls the story, and Newton was very, very good at controlling the story. Meanwhile, on the continent, mathematicians rallied behind Leibniz. They admired him, they used his notation, and they saw him as the clear innovator. Newton, in their eyes, was too secretive, too paranoid, too hidden in his English bubble. So the lines were drawn. England versus Europe. Newton versus Leibniz. Fluxions versus differentials. It wasn't just a math feud anymore, it was a cold war of ideas. And the fallout was serious. English mathematics, by clinging to Newton's system, began to fall behind. The great advances of the 1700s in calculus and analysis happened on the continent. France produced giants like D'Alembert and Lagrange. Switzerland produced the legendary Euler, who turned calculus into a universal toolkit. England, meanwhile, remained stuck defending Newton's honour instead of pushing the field forward. It's almost tragic. Newton had been the spark of the scientific revolution, but his feud with Leibniz slowed English progress for generations. His genius changed the world, but his pride kept his own country in the mathematical slow lane. Now let's add some humour to the picture. Imagine a 17th century math classroom in Paris. The students are happily scribbling hand signs, calculating slopes, solving problems with Leibniz's elegant dx notation. Across the channel in London, the students are scratching their heads over Newton's dots, wondering why everything looks like Morse code. One side is breezing through calculus, the other side is basically writing in emoji. No wonder Europe surged ahead. But from England's perspective, this wasn't funny, it was deadly serious. They believed their national hero was being robbed of his rightful glory. And if you think academic rivalries today can get messy, you haven't seen anything yet. Because soon Newton and his allies would stop whispering. They would go public. They would accuse Leibniz openly. And when they did, the calculus war would go from cold to scorching hot. But before we get to the pamphlets, insults and academic trash talk, remember this. At its core, the feud wasn't just about math. It was about identity. England versus Europe. Isolation versus openness. The secretive dragon versus the charming gentleman. And like any good rivalry, it was about pride. Pride so fierce, it blinded entire nations to the bigger picture. So as you drift off tonight, imagine the world of the late 1600s. On one side of the channel, Newton brooding in Cambridge, furious that his secret treasure has been stolen. On the other side, Leibniz publishing papers, writing letters, basking in admiration. Between them, a growing tension, like storm clouds gathering. The cold math war was on, and soon it would explode. Every great feud starts with a whisper, not a shout, not a fist fight, not a public declaration, just a quiet little murmur in the corner. Proust, I think he stole it. That's how the calculus war began to turn nasty. At first, Newton and Leibniz existed in a kind of uneasy peace. Newton knew he had invented calculus earlier, but he hadn't published. Leibniz had published, but likely without ever seeing Newton's secret notes. In a perfect world, they might have nodded politely and said, "Ah, we both discovered it, what a wonderful coincidence." But of course, that's not how human beings work, especially not geniuses with egos the size of planets. So around the late 1690s, the whispers began. Some of Newton's supporters in England started hinting that Leibniz's calculus looked suspiciously like Newton's fluxions. They pointed out that Leibniz had visited London years earlier and had seen some of Newton's manuscripts in passing. Was it possible, just possible, that Leibniz had borrowed a little too heavily? It didn't matter that there was no real evidence. It didn't matter that the two systems were different in style and notation. Once the rumour escaped into the wild, it grew legs. And Newton. Oh, Newton loved this rumour. He didn't start it, but once it was out there, he embraced it with the enthusiasm of someone finding proof that their rival had been cheating all along. In Newton's mind, it wasn't just a rumour, it was justice. finally the world would know that Leibniz had stolen his treasure. Of course, if you were Leibniz, this was deeply insulting. Imagine spending years developing your own brilliant system, publishing it, perfecting it, and then hearing your rival across the channel whispering, "Nice work, shame you copied it from me." It's the academic equivalent of someone looking at your homemade lasagna and saying, "Yeah, but you probably just microwaved it from the store." So Leibniz defended himself. He insisted he had discovered calculus independently. He pointed to the fact that his notation was completely different. He argued, quite reasonably, that great ideas can sometimes be discovered by more than one person at the same time, and in truth, history is full of these multiple discoveries. Electricity, evolution, even the telephone, all invented by different people, sometimes within months of each other. Calculus was one of those ideas whose time had simply come. But logic doesn't stop gossip. The whispers spread. Letters flew between England and the continent. Scholars started to take sides. Was Leibniz a thief? Was Newton just jealous? Which version of the story was true? The tension simmered, and like all good gossip, it only grew with retelling. Each side exaggerated. English mathematicians claimed Leibniz had peeked at Newton's notes and copied them. European mathematicians scoffed and said Newton was sulking because he didn't publish in time. And then slowly the whispers turned into something louder. By the early 1700s, the calculus controversy was no longer just a background murmur. It was becoming a full-blown public debate. Pamphlets started to appear, thinly veiled critiques not naming names but clearly pointing fingers. Letters dripped with sarcasm. Academic articles included little digs aimed at a certain Englishman or a certain German. It was 17th century subtweeting at its finest. And here's where Newton's personality really kicked in. Remember, this was a man who did not forgive easily. If you crossed him, he didn't just argue back, he declared war. And once the plagiarism rumour took root, Newton became convinced it was the truth. No amount of reasoning would convince him otherwise. In his mind, Leibniz wasn't just a rival, he was a fraud, a thief, an imposter daring to steal his rightful glory. Leibniz, meanwhile, was horrified. He thought the whispers were beneath him. He wanted recognition for his own brilliance, not accusations of theft. He wrote polite letters defending himself, sometimes less polite ones, but he never quite stooped to Newton's level of paranoia. Still, the stress began to eat at him. Being accused of plagiarism is bad enough today. Back then, it could destroy your reputation entirely. The saddest part is this. Both men were right, in a way. Newton really had invented calculus earlier. Leibniz really had invented it independently. But instead of sharing the credit, they each demanded total victory. Neither could bear the thought of being remembered as second place. And so the whispers became fuel. They spread through universities, across borders, into the halls of the Royal Society. Students, scholars, kings, everyone was hearing about the feud. And instead of focusing on the beauty of calculus, the world got caught up in the drama of who stole what. It's almost funny if you think about it. The greatest mathematical tool in history, the very system that would shape physics, engineering, and technology for centuries, was nearly overshadowed by academic gossip. It's like inventing the internet and then spending the next decade arguing about who invented the mouse pointer. But that's how pride works. That's how ego works. And in Newton's case, his ego was sharper than any sword. He was ready to fight. So the whispers of plagiarism set the stage. The polite society of scholars was about to get messy. Letters would turn into pamphlets. Pamphlets would turn into accusations. And accusations would turn into one of the dirtiest scientific wars ever fought. For now, though, picture the scene. Newton in England reading Leibniz's publications with narrowed eyes, muttering to himself, "He stole it. I know he stole it." Leibniz is in Germany, shaking his head in disbelief, thinking, why can't this man just share the credit? Two geniuses, one discovery, and a whisper that refused to die. When gossip turns serious, somebody always says, we need an investigation. And in the world of 17th century science, the big referee was the Royal Society of London. It was the most prestigious scientific club in England, full of wigs, quills, and men who enjoyed arguing about magnets, telescopes, and whether comets meant the end of the world. So naturally, when the whispers of plagiarism grew too loud to ignore, the Royal Society stepped in. Their mission? to figure out who really invented calculus. Was it Newton, the English hero, or Leibniz, the continental charmer? Time to settle this once and for all. Sounds fair, right? Except there was one tiny hilarious problem. Guess who just happened to be the president of the Royal Society at that exact moment? That's right, Isaac Newton. Imagine you're accused of stealing cookies from the jar. A committee forms to investigate, and then you're told, oh, by the way, the judge, jury and star witness will all be you. That was basically what happened here. Newton was in charge of the investigation into Newton's own claims. If this were a courtroom drama, the audience would have burst out laughing. But Newton didn't laugh. He got to work. The Royal Society created a report called the Commercium Epistolicum, which is Latin for the exchange of letters. Sounds innocent enough. It was supposed to be an impartial look at the evidence. Newton's old notes, Leibniz's publications, and the timeline of discoveries. But behind the scenes, Newton was the one pulling the strings. He secretly wrote large parts of the report himself. Then he presented it as the objective findings of the society. And surprise, surprise, the report concluded that Newton had invented calculus first, and that Leibniz was guilty of borrowing ideas. Not outright plagiarism, but enough shade to make Leibniz look suspicious. This was not just biased, it was basically academic fraud. Newton had turned the Royal Society into his personal weapon, and because the society was so respected, people believed it. Suddenly, the whispers of plagiarism weren't whispers anymore. They were official. They were published. They were stamped with the authority of England's greatest scientific institution. Leibniz, of course, was outraged. He protested. He wrote letters. He begged for fairness. But it didn't matter. Newton had the home field advantage. In England, the case was closed. Newton was the rightful inventor. Leibniz was the pretender. End of story. Well, end of story in England. On the continent, scholars weren't buying it. Mathematicians in France, Germany and Switzerland continued to side with Leibniz. They used his notation, they defended his reputation, and they mocked the English for being so blatantly biased. The divide only grew deeper. England had Newton, Europe had Leibniz, and calculus itself became a political football. Now, here's the part that makes it even funnier. Newton didn't just settle for writing the report. He also wrote anonymous pamphlets praising himself. Yes, really, he published reviews of the investigation under fake names, praising Newton's genius and dismissing Leibniz's claims. It was like leaving 5-star reviews for your own restaurant on Yelp. The chef is brilliant, best food in the world, definitely not the chef writing this review. This tells you a lot about Newton's personality. He wasn't just a genius, he was also deeply insecure. He couldn't stand the idea of sharing credit. He wanted to crush Leibniz completely, to erase any doubt, to make sure history remembered him as the one true inventor of calculus. And to be fair, Newton wasn't entirely wrong. He really had discovered calculus earlier. He just couldn't admit that Leibniz had also done it independently. For Newton, it had to be all or nothing. And so he turned a brilliant shared discovery into a bitter zero-sum game. The consequences were huge. The feud poisoned European mathematics for decades. Instead of collaborating, English and continental mathematicians dug into their trenches. England clung to Newton's fluxions while Europe advanced with Leibniz's notation. As a result, England fell behind. By the time they finally embraced Leibniz's system in the 1800s, the continent had already raced ahead with giants like Euler, Lagrange and Laplace, all because Newton couldn't share the sandbox. Now let's step back for a moment. Imagine if these two men had worked together. Newton with his raw power of invention, Leibniz with his elegance and clarity. Together they could have created the ultimate version of calculus decades earlier and spared the world a century of bickering. But of course they didn't, because geniuses are still human, and humans love drama. So the Royal Society's investigation wasn't really an investigation at all. It was a show trial staged by Newton to cement his legacy. And cement it he did. In England, Newton became not just a hero, but an untouchable legend. The man who discovered gravity, light, motion and calculus. The man who could not be questioned. Leibniz, meanwhile, was left fuming in Germany, watching his reputation take hit after hit. He wrote letters defending himself, but they only made him look more desperate. His health began to decline. His friends began to worry. The accusations weighed heavily on him. It's almost tragic. Two men, two geniuses, both right in their own way, but unable to share credit. And instead of celebrating the miracle of calculus, the world got a bitter feud. A feud fueled by whispers, pride, and one very biased judge. So as you drift off tonight, think of Newton in his wig, sitting at the head of the Royal Society, editing the official report to praise himself, probably with a satisfied little smirk. And think of Leibniz, hundreds of miles away, sighing, shaking his head, and muttering, "Are you kidding me?" The war was no longer just whispers. It was official, it was published, and it was about to get very, very dirty. By this point, the calculus war had officially escaped the polite world of letters and journals. The whispers had become accusations, the accusations had become reports, and now the reports were mutating into something far more entertaining: pamphlets. If the Royal Society's Commercium Epistolicum was Newton's official court ruling, pamphlets were the street fight. They were the memes of the 17th century, cheap, easy to print, easy to spread, perfect for academic trash talk. And oh, did Newton and his supporters love pamphlets. One of the most infamous came from John Keel, a Scottish mathematician and die-hard Newton fanboy. In 1710, Keel published a piece accusing Leibniz of outright plagiarism. Not subtle hints, not delicate suggestions. Straight up, Leibniz stole Newton's calculus. You can imagine how well that went over with Leibniz. Spoiler, not well. He fired back, demanding a retraction, insisting his honour was being slandered. But instead of backing down, Newton's allies doubled down. More pamphlets, more accusations, more mudslinging. This was the 17th century version of subtweeting. Instead of posting vague tweets, they printed little booklets and handed them out. A certain German mathematician claims originality, but we all know where he peaked. It was petty, it was mean, and it was hilarious. Leibniz, for his part, wasn't above a little shade either. He published replies defending himself, pointing out Newton's secrecy, mocking the dot notation of fluxions. One can almost imagine him saying, "Really? You want the world to use dots over letters? What is this, algebra Morse code?" And it worked. On the continent, Leibniz's reputation still held strong. Mathematicians like the Bernoulli brothers in Switzerland rallied behind him, using his notation, extending his ideas, and happily throwing their own pamphlet punches at Newton's side. It was less about the math at this point and more about the drama. Scholars were trading insults disguised as scholarship. Lines like, "The method of a certain Englishman lacks clarity," or "The German's work shows suspicious similarities." Every polite phrase was a dagger hidden in velvet. Newton, of course, was not content to let his allies do all the fighting. Even though he was president of the Royal Society, basically science royalty, he still found time to write anonymous pamphlets attacking Leibniz. Yes, the man who discovered gravity was out here writing burner accounts. Imagine if Einstein had spent his evenings posting angry comments on Reddit under the username RelativityKing123. That's the level of pettiness we're talking about. The pamphlets weren't just insults, though. They also served as propaganda. Each side wanted to sway public opinion, to convince future generations that their version of events was the truth. Newton's camp painted Leibniz as a thief, a copycat who got lucky. Leibniz's camp painted Newton as a bitter recluse, jealous that someone else had beaten him to publication. And the sad part, both portraits had a grain of truth. Newton really was bitter, jealous and paranoid. Leibniz really did benefit from publishing later, but in a way that looked suspicious. The pamphlet war exaggerated everything, but it exaggerated from reality. Meanwhile, the actual mathematics was getting lost. Instead of working together to advance calculus, Europe was busy watching two of its greatest minds argue like children in a sandbox. Mathematicians who could have been collaborating spent their time writing essays with titles like "A Refutation of the Most Scandalous Accusations of a Certain Society." Catchy, right? The pamphlet war dragged on for years. Each new accusation was met with a counter-accusation. Each sarcastic jab earned a sarcastic reply. It was endless. If Twitter had existed, this feud would have trended every day. Fluxions versus differentials. But while the war was petty, it was also strangely entertaining. Scholars who normally wrote dry papers suddenly found themselves sharpening their wit, crafting insults and trying to outdo each other. The pamphlets became performances, a stage where Newton and Leibniz, through their proxies, could duel without ever meeting face to face. And here's the kicker. Newton won in England, and Leibniz won on the continent. Each side believed their hero had triumphed. In London, pamphlets declared Leibniz disgraced. In Paris and Berlin, pamphlets celebrated Leibniz as the true father of calculus. It was less about truth and more about whose story you chose to believe. One of the nastiest aspects was how personal it became. This wasn't just about math anymore, it was about character. Pamphlets attacked not just ideas but personalities. Newton was painted as paranoid and controlling. Leibniz was painted as sneaky and dishonest. The feud had become less of a debate and more of a soap opera. And in the middle of all this, the actual beauty of calculus, the way it described motion, the way it unlocked the secrets of the universe, was almost forgotten. Almost. Because even while the pamphlets flew, students were learning Leibniz's notation, solving problems, pushing mathematics forward. Calculus itself didn't care who invented it, it just worked. Still, the pamphlet war left scars. Leibniz especially was worn down. He spent his final years fighting not just for recognition but for his reputation. The constant accusations of plagiarism haunted him, and the endless pamphlet battles chipped away at his health. Newton, meanwhile, grew ever more smug, convinced he had secured victory, even if it meant poisoning English mathematics for generations. So next time you hear someone complain about academic drama today, remind them, at least nobody is printing pamphlets in Latin to accuse each other of stealing derivatives. The calculus war had gone public. It was loud, it was messy, and it was fueled by pamphlets, insults, and math trash talk. And it wasn't over yet. At this stage in the feud, calculus itself was no longer the star of the show. The math had already proven its worth. Students were using it. Scientists were applying it. And the world was moving forward. But Newton and Leibniz, they weren't satisfied. The question wasn't, does calculus work? It was, who gets the glory? And that question turned into a battle for reputation. Newton, by now president of the Royal Society, was already England's golden boy. He had gravity, he had optics, he had the laws of motion. He was basically science royalty. But for Newton, it wasn't enough. He wanted to be remembered as the father of calculus, the genius who gave the world its greatest mathematical weapon. Leibniz, on the other hand, had built his reputation on being the charming diplomat philosopher. He had friends across Europe, endless correspondence with other scholars, and a reputation as a man of letters. But the accusations of plagiarism threatened to stain everything. If people believed Newton's camp, Leibniz wouldn't just lose credit for calculus, he'd lose his honour. So the war escalated. Newton's allies in England were relentless. They published, they lectured, they whispered at every opportunity. Leibniz copied. For them, this wasn't just about defending Newton, it was about defending English pride. To admit Leibniz had invented calculus independently would mean admitting that England's hero wasn't unique, that Germany had matched him, and that was unthinkable. Across the Channel, Leibniz's allies fired back. The Bernoulli brothers, two mathematical prodigies from Switzerland, championed Leibniz's notation. Jakob Bernoulli and his younger brother Johann were like the calculus avengers, showing off just how powerful Leibniz's system was. They solved problems, created new formulas, and rubbed England's nose in the fact that fluxions couldn't keep up. It became less about proving who invented calculus first, and more about proving whose camp had the better mathematicians. England had Newton, yes, but beyond him things looked thin. The continent had Leibniz, the Bernoullis, and soon Euler, who would take calculus and run with it into the stratosphere. The reputational battle even spread into other fields. Leibniz mocked Newton's obsession with secrecy. Newton's supporters mocked Leibniz's philosophy, especially his idea that we live in the best of all possible worlds. They called it naive, silly, unrealistic. Voltaire even turned it into satire in his book Candide, poking fun at Leibniz's optimism. Imagine being so famous that people are still roasting your ideas in novels decades later. Meanwhile, Newton's reputation in England grew more intimidating by the day. He wasn't just respected, he was feared. Colleagues avoided crossing him. Young scientists learned quickly that to criticize Newton was to end their careers. His reputation became a weapon, a shield, and a crown all at once. But here's the strange irony. In trying so hard to protect their reputations, both Newton and Leibniz damaged them. Newton looked petty, paranoid, and vindictive. Leibniz looked defensive, desperate, and increasingly bitter as the years went by. They could have been remembered as two independent geniuses who gave humanity calculus together. Instead, history remembered them as bitter rivals who couldn't let it go. Let's pause for a fun image. Imagine the afterlife, Newton and Leibniz stuck in the same room for eternity. Newton in the corner, scowling, muttering about fluxions. Leibniz pacing back and forth, waving his arms, saying, "I told you I didn't steal it." It would be the most awkward eternity ever. But back to the 1700s. The reputational war was at full throttle. Leibniz's health began to suffer. He felt the sting of being excluded, mocked and questioned. He wrote long, frustrated letters defending himself, but each one made him look weaker. Newton, on the other hand, thrived in the shadows of power. He didn't have to defend himself publicly. His allies did it for him. He sat above the battlefield, orchestrating the moves, satisfied as long as Leibniz suffered. The reputational war also shaped how the rest of the world saw calculus. In England, students learned Newton's fluxions, and professors spoke of Leibniz with suspicion. On the continent, students embraced Leibniz's dx and Hullertray, and Newton was painted as a jealous recluse. The same discovery was taught in two different languages, with two completely different backstories. It was as if there were two parallel histories of calculus, one English, one European, and both sides insisted theirs was the true one. The irony is that calculus itself didn't care. Calculus didn't need a reputation, it just worked. The planets orbited the same way regardless of who got the credit. Apples still fell at the same speed. Curves still had slopes. Reality didn't take sides in the feud. But humans do. And for Newton and Leibniz, the fight for reputation became more important than the discovery itself. They weren't just battling over math. They were battling over immortality. Who would the textbooks remember? Whose name would echo through the centuries? In the end, both were remembered, but not in the way either of them wanted. Instead of a peaceful legacy, they became the stars of one of history's messiest academic feuds. A feud so legendary, we're still telling the story centuries later. So next time you hear the word calculus, don't just think of derivatives and integrals. Think of Newton and Leibniz, locked in their eternal struggle for reputation. Two geniuses, two egos, one discovery, and a battle that turned mathematics into a war zone. And the war still wasn't over. Because if pamphlets and insults weren't enough, the feud was about to get even more personal. The letters, the letters would take things to a whole new level. If pamphlets were the loud, messy public stage of the calculus war, letters were the private battleground. And sometimes private battles are even nastier than the public ones, because in letters the gloves come off. Newton and Leibniz wrote a lot of letters. They lived in an age when the only way to feud long distance was to pick up a quill and pour your feelings into a piece of parchment. There was no texting, no subtweeting, no YouTube reaction videos, just letters, long, detailed, often passive-aggressive letters. And these letters burned bridges. Let's start with Newton. His letters had a particular flavour, cold, sharp, and loaded with subtle venom. He rarely wrote, "Leibniz is a thief." No, Newton was too clever for that. Instead, he wrote things like, "It seems that certain individuals have made use of ideas not properly their own," which is 17th century code for, "You stole my homework, you fraud." Leibniz, in return, wrote with flair. He was a philosopher after all, and he had a knack for elegant turns of phrase. His letters defended his honour, but they also poked at Newton's insecurities. Leibniz would say things like, "If only some men of great repute were less secretive, perhaps the world would know more of their supposed discoveries." Translation: if Newton hadn't been such a hermit, we wouldn't be in this mess. Each side tried to sound polite, but the politeness was a thin mask. Underneath you could hear the teeth grinding. Imagine two people at a dinner party smiling and saying, "Oh, your dress is so interesting, I've never seen that style before." That's the tone these letters had. Civil on the surface, savage underneath. And they didn't just write to each other, they wrote about each other to everyone else. Scholars across Europe would open their mail and find Newton complaining about Leibniz or Leibniz warning about Newton. It was like being CC'd into an argument you never asked to be part of. Dear esteemed colleague, please enjoy my 20-page rant about why my rival is a fraud. One particularly sharp moment came when Leibniz complained about Newton's allies, especially John Keill, who had been one of the loudest accusers of plagiarism. Leibniz demanded that Newton, as president of the Royal Society, rein in these attacks. But Newton, of course, was the one secretly encouraging them. So his reply was the diplomatic equivalent of shrugging and saying, "Oh dear, what a shame. Can't imagine where they got such an idea." It was gaslighting at its finest. The longer the letter war dragged on, the more toxic it became. What had started as polite disagreements about math turned into personal insults about character, honesty and integrity. These weren't just mathematical arguments anymore. They were duels fought with ink. The irony is delicious. Two of the greatest minds in history, capable of calculating planetary motion and inventing entire branches of mathematics, reduced to writing glorified hate mail. It's the most human thing imaginable. Now let's talk about how exhausting this was for Leibniz. Newton had home advantage, he controlled the Royal Society, he had loyal allies, and his reputation in England was untouchable. Leibniz, meanwhile, was isolated. He lived in Hanover, surrounded by friends who supported him. Yes, but he couldn't match the political power Newton wielded in London. So Leibniz's letters became increasingly desperate. He begged for fairness. He insisted on his independence. He tried to remind people that notation mattered, that publishing mattered, that calculus wasn't just about who thought of it first, but about who gave it to the world. But the more he wrote, the weaker he looked. It was like watching someone defend themselves against gossip. They can shout it's not true all day, but the whispers never stop. Newton, on the other hand, was thriving. Each letter from Leibniz only confirmed his suspicions. Each protest sounded to him like guilt, and Newton, being Newton, saved every scrap of correspondence, filing it away like evidence in a trial he was determined to win. The tragic part is that these letters didn't just burn bridges between Newton and Leibniz. They burned bridges between England and the continent. The feud polarized mathematics across Europe. English scholars stopped collaborating with continental ones. The two sides drifted further apart, not just in politics but in mathematics itself, all because two men couldn't share credit. And yet for us, centuries later, the letters are pure entertainment. They're historical gossip. They let us peek into the egos of two men who shaped the modern world, but who also acted like rival teenagers arguing over who started a band first. Imagine Newton writing, "I had the idea years ago in my notebooks, everyone knows it," and Leibniz replying, "Ideas don't count unless you publish them, everyone knows that." And then Newton muttering, "Well, everyone in England knows I'm right," and Leibniz sighing, "Everyone on the continent knows I'm right." Back and forth forever. By the end, the letters had done their damage. Whatever small chance there had been for reconciliation was gone. Newton and Leibniz were never going to be friends, never going to acknowledge each other fairly. The bridges were burned, the camps were divided, and the calculus war had become personal beyond repair. So as you get sleepy tonight, picture this. Not two geniuses at chalkboards, not two men gazing at the stars, but two grown adults furiously scratching quills across paper, writing the 17th century version of "You Stole My Idea." The ink smudges, the candles burn low, the letters fly across Europe like little bombs, each one making the feud worse. Letters that could have built collaboration instead burned every bridge they touched. And the war raged on. So far, this whole feud might sound like nothing more than a petty academic squabble. Two brilliant men fighting over bragging rights, trading pamphlets, firing off letters, dragging their followers into the mud. Entertaining, yes, but maybe also a little silly. But here's the thing, there was a lot more at stake than bruised egos. This wasn't just about Newton and Leibniz. It was about nations, pride, and the very future of science. Let's start with England. In the late 1600s and early 1700s, England was still finding its scientific identity. The Royal Society was relatively new, and the country desperately wanted to show that it could keep pace with the intellectual powerhouses of Europe. France, Germany, Italy. Having Newton as their superstar was like England having their own scientific rock star. He was proof that England could produce a mind as brilliant as Galileo or Descartes. So when Leibniz came along, publishing calculus first and dazzling the continent with his elegant notation, it wasn't just a personal threat to Newton, it was a national threat. If people believed Leibniz had invented calculus, it would mean England's greatest treasure wasn't quite so unique. Newton's defenders weren't only protecting his pride, they were defending England's scientific reputation. On the flip side, Europe had its own reasons for rallying behind Leibniz. France and Germany weren't about to let England claim dominance in the most powerful new branch of mathematics. Supporting Leibniz wasn't just about the truth of his discoveries, it was about resisting English influence. For the French, the German and the Swiss mathematicians, Leibniz was their champion, their banner in the scientific arena. So what looked like two men fighting over symbols was actually two continents locking horns. It was science as a proxy for politics. But that's only part of the story, because beyond the national pride, there was also the matter of how mathematics itself would move forward. This feud wasn't happening in a vacuum. The world was on the edge of a scientific revolution. Calculus wasn't just an abstract idea. It was the key to unlocking physics, astronomy, engineering, even economics. Whoever controlled calculus controlled the language of science. Think about it. Without calculus, there is no modern physics. No rockets, no bridges, no skyscrapers. Without calculus, you can't model disease, design engines, or send humans to the moon. In the 17th century, people didn't know all of this yet, but they could feel the power of the new tool, and they knew that whichever system, Newton's fluxions or Leibniz's differentials, became standard would shape the way science was written for centuries. So yes, there was pride, but there was also legacy. Not just who invented this, but whose system will the world use? That's why the battle got so fierce. And here's the irony. While Newton obsessed over protecting his reputation, England actually fell behind. By clinging to his fluxions and refusing to adopt Leibniz's simpler notation, English mathematicians isolated themselves. On the continent, Leibniz's notation spread like wildfire. Students found it easier to use, teachers found it easier to explain, and out of that notation grew an explosion of discoveries. Euler, Lagrange, Laplace, and the great wave of continental mathematics. In other words, Newton may have won the battle in England, but Leibniz won the war in the rest of the world. And what was at stake wasn't just credit, it was progress itself. There's another layer too, one that's more personal. In the early modern world, reputation wasn't just about fame, it was about survival. A good reputation meant support, patronage, funding, even job security. A bad reputation could mean losing everything. Newton, by the time of the feud, didn't have to worry much. He was secure, wealthy and powerful. But Leibniz, he depended on his reputation. He worked as a court advisor, a diplomat, a historian. He needed people to believe in his brilliance to keep his career alive. The accusations of plagiarism weren't just bruising his ego, they were threatening his livelihood. For him, the stakes were survival. And maybe that explains why Leibniz fought so hard, even when the stress was ruining his health. For Newton, the feud was about pride. For Leibniz, it was about existence. So what was really at stake in the calculus war? Everything. National pride, scientific progress, personal survival, and the future of mathematics itself. It wasn't just two men bickering. It was a microcosm of how science actually develops. Messy, human, full of conflict, shaped as much by egos and politics as by truth and reason. And that's the part that still resonates today. We like to imagine science as this pure, objective quest for knowledge, free from drama, but the calculus war reminds us that science is a human endeavour. It's done by people with all their flaws, biases, and rivalries. The beauty of calculus was born out of ugliness, and yet it still changed the world. So maybe the moral is this: human beings will always fight, but knowledge finds a way to move forward anyway. Now, as you drift towards sleep, picture the bigger stage. Not just Newton and Leibniz in their candlelit rooms, but nations, institutions, and future generations watching their feud play out. The world didn't just get calculus, it got a story about how fragile and fiery genius can be. And we're still telling it centuries later. When the dust of the calculus war finally began to settle, there was one question that mattered more than any accusation, any pamphlet, or any bitter letter. Not who invented calculus first, but whose version would the world actually use? Because let's be honest, math is not just about ideas, it's about communication. If you can't write it down in a way that other people understand, it doesn't matter how brilliant the idea is. And here's where Leibniz absolutely crushed Newton. Newton's system, which he called fluxions, was powerful but clunky. Imagine trying to learn an entire new language just to talk about slopes and curves, and then realizing the words don't quite fit together. Newton used dots over variables to represent rates of change. It worked, but it wasn't intuitive. It looked like secret code, something only Newton and his closest followers could decode. Leibniz, on the other hand, gave us the system we still use today, the dx and dy, the tundrit sign that looks like a stretched out S, standing for sum. His notation wasn't just clever, it was beautiful. It captured the very idea of calculus in a way that felt natural. Tiny changes, infinite sums, smooth and elegant. Students loved it, teachers loved it, mathematicians loved it. In fact, the more you use calculus, the more you realize that Leibniz's symbols almost explain themselves. They invite you in rather than shutting you out. And that's the secret. Newton may have discovered calculus first, but Leibniz published it first and packaged it better. History is full of examples where the person who communicated best won the legacy, not the person who invented first. Think of Thomas Edison, who didn't invent the light bulb but made it famous. Or Steve Jobs, who didn't invent computers but made them irresistible. Leibniz was the Steve Jobs of calculus. He turned raw genius into a user-friendly product. The impact was enormous. On the continent, Leibniz's notation spread like wildfire. Within a generation, mathematicians like the Bernoulli brothers were building entire new theories using it. Soon after, Euler, the Mozart of mathematics, took Leibniz's symbols and turned them into music. Differential equations, infinite series, exponential functions, all written in Leibniz's style. England, meanwhile, stubbornly stuck to Newton's fluxions, and that decision cost them dearly. For nearly a century, English mathematics lagged behind, while continental Europe soared ahead, producing Euler, Lagrange, and Laplace. England produced silence. It wasn't that the English mathematicians weren't smart, they were just working with clunkier tools. Trying to compete with fluxions against Leibniz's notation was like trying to write a novel using only emojis. By the 1800s, even England had to admit defeat. Fluxions quietly faded away, and Leibniz's notation became the international standard. Today, every calculus textbook in the world, from Tokyo to Toronto, from Sao Paulo to Stockholm, uses dx and fam re. Newton's dots survive only in history books. And that's a strange kind of justice. Newton may have won the political war in his lifetime, but Leibniz won the war of the future. His symbols became the language of science. His way of writing calculus shaped how generations of students would think about change, motion, and infinity. There's also something poetic about it. Newton was obsessed with control, secrecy, and ownership. He hid his method in notebooks for years. He guarded his discoveries like treasure. Leibniz, in contrast, published freely, wrote letters, shared his ideas, and in the end, the sharer won. The man who opened his hand left a greater legacy than the man who clenched his fist. Of course, for students today, the legacy is mixed. On one hand, Leibniz's notation is brilliant. On the other hand, it's also the reason countless teenagers stare at their homework and groan. What on earth is this squiggly S doing here? Leibniz gave us beauty, but also headaches. Maybe that's the fate of all great mathematicians, to be loved and cursed in equal measure. Still, if you've ever taken a calculus class, you've felt the weight of this legacy. Every time you write Hev x dx, you're echoing Leibniz. Every time you find the slope of a curve using div dex, you're walking in his footsteps. His notation is not just a tool, it's a living memory of the man who fought, lost, and yet somehow still won. Newton, for all his genius, didn't leave us that. His fluxions were too narrow, too clumsy, too tied to his own way of thinking. They didn't survive because they couldn't be shared, and that's the quiet lesson of this whole feud. Discoveries don't belong to individuals, they belong to the world, and the world chooses which version to keep. So, what was the legacy of the notation? It was victory through elegance. It was the triumph of communication over secrecy. It was a reminder that even in the dirtiest academic feud, sometimes the better idea shines through anyway. And maybe, just maybe, that's the bedtime moral tucked inside the squiggly S. No matter how bitter the war, no matter how heavy the egos, in the end the math wins, the beauty wins, and the world moves forward. When the dust of the calculus war finally began to settle, there was one question that mattered more than any accusation, any pamphlet, or any bitter letter. Not who invented calculus first, but whose version would the world actually use. Because let's be honest, math is not just about ideas, it's about communication. If you can't write it down in a way that other people understand, it doesn't matter how brilliant the idea is. And here's where Leibniz absolutely crushed Newton. Newton's system, which he called fluxions, was powerful but clunky. Imagine trying to learn an entire new language just to talk about slopes and curves, and then realizing the words don't quite fit together. Newton used dots over variables to represent rates of change. It worked, but it wasn't intuitive. It looked like secret code, something only Newton and his closest followers could decode. Leibniz, on the other hand, gave us the system we still use today, the dx and dy, the tall sign that looks like a stretched out S, standing for sum. His notation wasn't just clever, it was beautiful. It captured the very idea of calculus in a way that felt natural. Tiny changes, infinite sums, smooth and elegant. Students loved it, teachers loved it, mathematicians loved it. In fact, the more you use calculus, the more you realize that Leibniz's symbols almost explain themselves. They invite you in rather than shutting you out. And that's the secret. Newton may have discovered calculus first, but Leibniz published it first and packaged it better. History is full of examples where the person who communicated best won the legacy, not the person who invented first. Think of Thomas Edison, who didn't invent the light bulb but made it famous, or Steve Jobs, who didn't invent computers but made them irresistible. Leibniz was the Steve Jobs of calculus. He turned raw genius into a user-friendly product. The impact was enormous. On the continent, Leibniz's notation spread like wildfire. Within a generation, mathematicians like the Bernoulli brothers were building entire new theories using it. Soon after, Euler, the Mozart of mathematics, took Leibniz's symbols and turned them into music. Differential equations, infinite series, exponential functions, all written in Leibniz's style. England, meanwhile, stubbornly stuck to Newton's fluxions, and that decision cost them dearly. For nearly a century, English mathematics lagged behind, while continental Europe soared ahead, producing Euler, Lagrange and Laplace. England produced silence. It wasn't that the English mathematicians weren't smart, they were just working with clunkier tools. Trying to compete with fluxions against Leibniz's notation was like trying to write a novel using only emojis. By the 1800s, even England had to admit defeat. Fluxions quietly faded away, and Leibniz's notation became the international standard. Today, every calculus textbook in the world, from Tokyo to Toronto, from Sao Paulo to Stockholm, uses dx and tan. Newton's dots survive only in history books. And that's a strange kind of justice. Newton may have won the political war in his lifetime, but Leibniz won the war of the future. His symbols became the language of science. His way of writing calculus shaped how generations of students would think about change, motion, and infinity. There's also something poetic about it. Newton was obsessed with control, secrecy, and ownership. He hid his method in notebooks for years. He guarded his discoveries like treasure. Leibniz, in contrast, published freely, wrote letters, shared his ideas, and in the end, the sharer won. The man who opened his hand left a greater legacy than the man who clenched his fist. Of course, for students today, the legacy is mixed. On one hand, Leibniz's notation is brilliant. On the other hand, it's also the reason countless teenagers stare at their homework and groan, "What on earth is this squiggly S doing here?" Leibniz gave us beauty, but also headaches. Maybe that's the fate of all great mathematicians, to be loved and cursed in equal measure. Still, if you've ever taken a calculus class, you've felt the weight of this legacy. Every time you write temp and fx dx, you're echoing Leibniz. Every time you find the slope of a curve using dx, you're walking in his footsteps. His notation is not just a tool, it's a living memory of the man who fought, lost, and yet somehow still won. Newton, for all his genius, didn't leave us that. His fluxions were too narrow, too clumsy, too tied to his own way of thinking. They didn't survive because they couldn't be shared, and that's the quiet lesson of this whole feud. Discoveries don't belong to individuals, they belong to the world, and the world chooses which version to keep. So what was the legacy of the notation? It was victory through elegance. It was the triumph of communication over secrecy. It was a reminder that even in the dirtiest academic feud, sometimes the better idea shines through anyway. And maybe, just maybe, that's the bedtime moral tucked inside the squiggly S. No matter how bitter the war, no matter how heavy the egos, in the end, the math wins, the beauty wins, and the world moves forward. While Leibniz faded quietly into obscurity, Isaac Newton was living what we might call the celebrity scientist dream. Well, as much of a dream as it could be for someone as famously grumpy as Newton. By the early 1700s, Newton was the unquestioned king of English science. He was president of the Royal Society, master of the Mint, knighted by Queen Anne, and universally regarded as the greatest genius of the age. He didn't just have fame, he had power. Real, practical, terrifying power. Let's talk about that mint job for a moment. Newton wasn't just sitting in an office counting coins, he basically reformed the entire English currency system. In the 1690s, England's coins were a mess. People shaved the edges off silver coins to steal slivers of precious metal, then used the shaved coins in circulation anyway. It was financial chaos. Enter Newton. He took over as warden of the mint, and later as master of the mint, and he went full detective mode. He tracked counterfeiters, chased smugglers, and personally interrogated suspects. In fact, he sent quite a few forgers to the gallows. Imagine the same man who discovered gravity, now serving as part-time crime boss, cleaning up London's underworld with cold precision. Newton didn't play, and he wasn't shy about it either. He brought the same relentless, obsessive energy to money as he had to physics. To him, every problem, whether falling apples or falling currencies, was just another puzzle to solve. And of course, he solved it. England's financial system stabilized, and Newton became not just a scientist, but a national hero. But fame didn't make him soft. If anything, it made him harder. Newton had always been secretive, always defensive. Now, with power in his hands, he became intimidating. Colleagues feared him. Younger scientists knew better than to cross him. The Royal Society became less a forum for open debate and more Newton's personal kingdom. And his grudges? Oh, Newton never let those go. His feud with Leibniz was only one of many. Earlier in his career, he'd had a nasty clash with Robert Hooke over optics. Newton believed Hooke had downplayed his discoveries, and when Hooke died in 1703, Newton supposedly made sure no portrait of him survived. Today, we don't have a confirmed image of Hooke, and some historians suspect that's Newton's pettiness reaching across time. Imagine holding a grudge so strong you erase someone's face from history. He also quarrelled with John Flamsteed, the astronomer royal, who had provided Newton with star charts to help with Principia Mathematica. When Newton felt Flamsteed wasn't cooperative enough, he used his influence to seize Flamsteed's data and publish it without permission. Later, Flamsteed won a court battle to have the copies burned, but the damage was done. Newton once again had gotten his way. So yes, genius and grumpiness went hand in hand. Newton was brilliant, no doubt, but he was also prickly, controlling, and often downright ruthless. But here's the funny part. Despite his harsh personality, the public adored him. When he walked into a room, people whispered. When he spoke, people listened. His funeral in 1727 was practically a royal affair, carried out with pomp, music, and a grand burial in Westminster Abbey. Newton wasn't just remembered as a scientist, he was remembered as a national treasure. And maybe that's the difference between him and Leibniz. Newton knew how to play the power game. He didn't just make discoveries, he built institutions, cultivated patrons, and positioned himself at the very centre of English intellectual life. Leibniz, with all his charm, spread himself too thin. He tried to be everything, philosopher, diplomat, historian, mathematician, and ended up with nothing secure. Newton, by contrast, focused his firepower, and he held on to power until the very end. Yet, for all his success, Newton never seemed particularly happy. He lived long, yes, but not joyfully. He was solitary, suspicious, and famously short-tempered. Even his friends admitted he wasn't exactly easy company. One described him as a man not to be contradicted, which is a polite way of saying, don't argue with Isaac. You can almost picture him in old age, sitting in a grand chair, wig slightly crooked, muttering to himself about fluxions, alchemists, and who stole what idea back in 1675, surrounded by wealth and honour, but still restless, still defensive, still Newton. And that, maybe, is the bittersweet truth. Newton won in his lifetime, no question. He had the fame, the money, the funeral, the legend, but history has a longer memory than a single lifetime. Today we remember Newton as a towering genius, but we also remember the darker side, the paranoia, the grudges, the endless need to control. Leibniz may have died forgotten, but his symbols live in every textbook. Newton may have died celebrated, but his fluxions are gone. In the end, they both left legacies that were brilliant and flawed, glorious and human. So as you drift towards sleep, picture Newton in those final years, surrounded by books and coins, weighed down by a wig the size of a small sheep, sipping wine, still calculating, still plotting, still carrying every grudge he ever had. A man who could bend the universe into equations, but who never quite learned how to bend his own pride. Genius and grumpiness, hand in hand, right to the very end. After 2 decades of pamphlets, letters, and whispered insults, one big question still hovers in the air. Who actually won the calculus war? On the surface, the answer seems easy. Newton, of course. He was the hero of England, president of the Royal Society, knighted, honoured, buried in Westminster Abbey with the kind of funeral usually reserved for kings. Leibniz, meanwhile, died in relative obscurity, with only a handful of mourners and no royal recognition. If you're scoring it like a boxing match, Newton looks like the clear winner. But history is not a boxing match. It's messier. And the more you look at the calculus war, the more you realise that victory depends on what exactly you mean by won. Let's break it down. If the prize was fame during their lifetime, then yes, Newton won hands down. His prestige in England was unmatched. His name was celebrated far and wide, and he died with a nation at his feet. Leibniz couldn't compete with that. He spent his last years defending himself against accusations and worrying about his reputation. By that measure, it's Newton's victory. But if the prize was which system of calculus the world actually adopted, then Leibniz was the winner. His notation, the dx die, the beautiful stone sign, became the universal language of mathematics. Newton's fluxions disappeared. Outside of England, almost nobody used them. By the 1800s, even England gave up and switched. If you've ever taken a calculus class, you've written Leibniz's symbols, not Newton's. So on the scoreboard of legacy, Leibniz takes the crown. And if the prize was who pushed mathematics further forward, the answer is complicated again. Newton's calculus was tied tightly to his physics. He used it to explain gravity, planetary motion, optics, the works. He gave science the Principia, which changed everything. Leibniz, meanwhile, made calculus into a flexible tool, something anyone could pick up and apply to new problems. He turned it into a language, not just a method. In other words, Newton lit the rocket, but Leibniz built the engine that everyone else could use. Without both of them, the revolution in science and mathematics wouldn't have happened. So maybe the answer isn't Newton or Leibniz. Maybe the answer is both. But of course, that's not what either man wanted to hear. Newton didn't want to share credit with anyone. Leibniz didn't either. Both wanted to be the inventor, not just an inventor, and that's why the war became so bitter, because compromise was impossible when pride was at stake. What's fascinating is how this story reminds us that science is not as clean as we like to imagine. We like to picture discoveries happening in neat, tidy steps. A genius has an idea, writes it down, and the world changes. But in reality, it's messy. Ideas brew in many places at once. People influence each other, borrow from each other, sometimes knowingly, sometimes not. And then they argue about who was first. The calculus war is the perfect example of this messiness. Newton and Leibniz both arrived at the same great discovery, in different ways, at roughly the same time. Neither could have fully claimed it without the other. And yet, instead of celebrating that coincidence, they turned it into a battle of egos. In the end, maybe that's the real winner, calculus itself. The feud was dirty, the insults were petty, but the math that came out of it changed the world. Ships crossed oceans with new precision, planets were tracked across the skies, bridges were built, rockets launched, economies modelled. Humanity leapt forward, carried on the back of an idea born in secrecy. published in elegance, and fought over with fury. If Newton and Leibniz could see us now, our satellites, our skyscrapers, our laptops, they might still bicker about who deserves the credit. Newton would mutter, "It was my fluxions that explained the heavens." Leibniz would counter, "It was my notation that let the world understand." And both in a way would be right. So who won the calculus war? Maybe not Newton, maybe not Leibniz, maybe it was us. We, the people who inherited their discovery, who use it every day without even realizing it. Every time a plane lands safely, every time a computer renders a video game, every time a doctor models the spread of a disease, calculus is there quietly working in the background. We are the beneficiaries of their feud. And maybe that's the funniest twist of all. Newton and Leibniz spent years clawing at each other, desperate to secure their place in history. But history doesn't belong to them anymore. It belongs to everyone who uses their ideas. So as you sink into sleep, remember this. The war was ugly, but the outcome was beautiful. The men were flawed, but the math was flawless. And in the end, the real winner wasn't Newton or Leibniz. It was calculus itself, and the entire human race that got to use it. So here we are. After Newton's grumpiness, Leibniz's loneliness, the pamphlets, the letters, the gossip, the insults, the fluxions and the Fajm signs, we've reached the end of the calculus war. And maybe you're wondering, what's the point of all this? What's the bedtime moral? Because every good story, even one about math, deserves a moral. Maybe it's this. Human beings can make even the most beautiful discoveries messy. Calculus, arguably one of the most powerful tools ever invented, wasn't born out of peaceful cooperation or noble teamwork. It was born out of rivalry, secrecy, jealousy, and pride. Two geniuses staring at infinity and then glaring at each other. That's as human as it gets. But here's the twist. Even though the war was ugly, the math was beautiful. The feud ended careers, ruined friendships, burned bridges. But it couldn't stop the idea itself. Calculus slipped out of the quarrel like a shining coin dropped into the mud. No matter how much dirt the two men threw at each other, the brilliance of the math stayed untarnished. So maybe the moral is this. People fight, but knowledge survives. Think about it. Newton wanted calculus to be his private treasure, hidden in notebooks guarded like gold. Leibniz wanted it to be a universal language, shared and spread across the world. And in a way, both got their wish. Newton gave calculus its first secret spark. Leibniz gave it its voice. And together, though they would have hated to admit it, they gave it to us. Another moral might be this. Communication matters. Newton may have been the greater genius, but his dots and fluxions didn't survive. Leibniz, with his elegant notation, created something anyone could use. It wasn't just about discovering, it was about sharing. That's why students today write DX instead of .x. It's not the discovery that survives, it's the story. And maybe, as you're drifting towards sleep, you can smile at how petty it all was. Imagine Newton and Leibniz, two of the smartest men in history, bickering like kids in a sandbox. I had it first. No, I had it first. You copied me. No, you copied me. For all their brilliance, they couldn't escape being human, and that's oddly comforting. If even geniuses can be this messy, maybe the rest of us are doing just fine. There's also a gentler moral. Sometimes you don't need to decide who was right. Sometimes it's enough to say both. Both men were brilliant. Both men shaped the future. Both men deserve credit. And both men, through their feud, gave us a story that's been told for 300 years. A story so rich, so funny, so tragic, that you're lying here tonight, listening to it instead of counting sheep. And finally, the simplest moral of all. In the end, the math wins. The war fades, the egos vanish, the insults are forgotten, but the equations live on. Every rocket, every bridge, every computer model is a quiet monument to the messy genius of Newton and Leibniz. They may have fought bitterly, but they left us calculus, and that's a bedtime gift worth keeping. So as your eyes grow heavy, let's close the book on the great calculus war. Two geniuses, one feud, and a discovery too big to be owned by either of them. The war was dirty, the math was beautiful, and in the end the world got calculus because two sleepless men couldn't share their toys. Good night.